Okay, hello everyone. I welcomes to all in our lecture series on fiber optics. In this lecture series, we are discussing these topics, which are most essential for BSc, BTech, MSc, MTech, and various entrance examinations. In our previous classes, we discussed these two topics. In this class, we are going to discuss fractional refractive index change and numerical aperture. Okay, so let us start. In our first class, we discussed the introduction and principle of data propagation. Then we discussed acceptance angle and acceptance cone in detail. Derivation of acceptance angle also we discussed in our last class. In this class, we are going to discuss first fractional refractive index change and then numerical aperture. Here is the definition of this fractional refractive index change. This one. The fractional difference between the refractive indices of core and cladding is known as fractional refractive index change, represented by del. Or you can write the ratio between difference between core and cladding. This is the refractive index of core and this is the refractive index of cladding. Okay. So also you can write the difference between the refractive indices of core and cladding with respect to core is nothing but your fractional refractive index change. Okay, just remember this expression, which is essential for different questions numerical that you are going to solve in your exam. Okay, now we are going to go for numerical aperture. It is a very simple definition. It is defined as numerical aperture defined as the sign of acceptance angle, which is nothing but theta 0, na equal to sine of theta 0. That's it. Previously we found sine theta 0 equal to n1 square minus n2 square root over. This is the refractive index of core. This is the refractive index of cladding. May you remember when we calculated the acceptance angle at that time. Here we found sine theta 0 in our previous class. We discussed this much, n1 square minus n2 square whole root over. Same thing we written over here. Sin theta 0 equal to this one, or numerical aperture is nothing but n1 square minus n2 square root over. Now here n1 square minus n2 square can be written as n1 plus n2 into n1 minus n2. Right. Here I just divided 2 and multiplied with 2. So this expression will be written as n1 plus n2 by 2. Here n1 minus n2 into 2 and n1 and n2 divided and multiplied. Right. Approximately it can be found that the mean value of the refractive indices of core and cladding is equivalent to refractive index of core. n1 plus n2 by 2, approximately it can be found n1 only. So the above expression can be written as n1 square minus n2 square will be equal to, here this value will be n1. So 2 n1 into n1 square, and this is nothing but your fractional difference between refractive indices n1 minus n2 by n1, which is represented by del. Okay, so that numerical aperture is the root over of this factor n1 square minus n2 square. So numerical aperture will be equal to now root over of this one, 2n1 square del whole root over. We can found n1 square is there, so root over will be removed, n1 into 2 del root over. You just remember this expression, which is essential to solve various numerical. Okay, here I am going to stop this class. Next class we are going to solve some important numericals based upon acceptance angle, acceptance cone, numerical aperture, and fractional difference between the refractive indices. Okay, thank you so much for watching this video. Thank you.